We discuss now some standard functions which are very important as far as even 12 standard concerns. So the first function, which is called identity function. Identity function. So it is usually denoted by capital I from real numbers to real numbers, function from R to R. Here definition is image of x will be that element itself for every x. This is read as for every. You may not be knowing. This is read as for every. This is a standard symbol. We read as for every. So for every x. So in this function, image of an element is itself. So this function has no effect. If I take for example fx equals to x square, you recall, then here image of 1 is 1 square, which is 1. Image of 2 square, which is 4. So here the corresponding member would be its square. Here the corresponding member is itself. Like this, if I have a function from, for example, a to a, suppose here I have 1, 2, 3, here also you must have the same. For identity function, domain and codomain are always equal, remember. So 1 goes to 1, 2 goes to 2, 3 goes to 3. So this is an example of identity function. I of x equals to x. So here I of 1 is 1, I of 2 is 2, I of 3 is 3. This is an identity function. Image of an element is itself. If it is a function from R to R, then sometimes it is written as IR here, IR here. Here it is a function from A to A, so we write IA, IA. Identity function, remember. That's one. Here you can see that range would be the domain itself here. Range of this function, range would be R, domain itself. Because here if I pick up every member, then image will be itself. So range will be R. That is one. Second, we go to constraint function. Constraint function. Next type, which is a constraint function. Now, I'll take a function f from real numbers to real numbers, for example. Look at this function. Here you have a number of members in this domain. Here also you have number of members. So suppose if I take like this here, then every member of the domain goes to one fixed member. So such a function is called constraint function. This is a function, remember. So it is defined like fx equals to c, where c is some constant, fixed constant. So if I take 1, then image, suppose I'll take here, let me take 2. The image of 1 is 2. If I take 2, image of 2 is 2. If I take 3, image of 3 is 2. If I take 4, image of 4 is 2 again, and so on. So every member of the domain are associated with one fixed number. Let me call that as c. So that's a constant here. So such a function is called constant function. F from real numbers to real numbers. This is known as constant function. For example, so there is no variable on RHS. It is a constant. You see here variable x, but it's not on RHS. Here variable is there. Like this, fx equals to 2. There is a constant function. Fx equals to 10, constant function. Fx equals to 0, constant function. So here every member are connected with 0, every member are connected with 10, every member is connected with 2. So this is a constant function. What's the range of such constant function? Range RF will be, here range is set of images. Every member goes to 2, so range will be 2. Here every member goes to C, so singleton C, which is a singleton set. Singleton set. Any function whose range is this, a function, you can write like this, a function with range equals to singleton set, range equals to singleton set is a constant function, is a constant function, is a constant function. You see here range is not singleton set, here it is R, so this is not. So these are the two functions. One is called identity, the other one is called constant. Next is we write linear function. Then we generalize this, which is called quadratic, and further we have polynomial function. So linear, quadratic and polynomial function. So I'll first write linear function. So a function from real numbers to real numbers defined in this way: fx equals to ax plus b, where a and b be some constants. These are some constants, and a should not be 0. Such a function is called linear function, is called linear function, is called linear function. Linear, or sometimes it is called straight line function, straight line function. So a function from real numbers to real numbers defined in this way: ax plus b, where x is a variable. Any function which is of this type, like this, if I write fx equals to 2x plus 1, 4x plus 3, 1 by 2x plus 3, 4x, minus 1 by 2x, minus 7x plus 3, all are linear functions. These are nothing but linear functions. Here a is 1, a is 2, b is 1, a is 4, b is 3, a is 1 by 2, b is 3. This a is 4, b is 0, a is minus 1 by 2, b is 0. Your a is minus 7, b is 3. So I've just chosen different values of a and b, remember. What important thing you notice is here everywhere power of variable x is 1. You see exponent of x is 1. If I write like this, for example, these are all linear functions, all linear functions. If I write this 4x square plus 1, not a linear, because here power is 2. This is not a linear function, not a linear function. So this is very important function we'll use frequently. Exponent of variable x is 1. This is called linear function. It's a function from R to R, remember. A should not be 0. If a is 0, then this is just a constant, so it becomes a constant function. So 1. Now here you take any function out of this. Suppose I would take an fx equals to, suppose 2x plus 1. Now if I take different values of variable x, so here suppose if I start with this function, let me take different members from the domain which is R here. So f of 0, 2 into 0, 1, f of 1 by 2. So 2 into 1 by 2 plus 1, which is 2. Your domain is real numbers, so you can choose any number. If I take minus 1 by 2, so 2 into minus 1 by 2 plus 1, which is 0. If I take f of 1, for example, so it is 3. If I take f of 2, then here 5. If I take f of 3, then 7. If I take f of minus 3, then minus 6 plus 1, minus 5. If I take minus 1, then minus 2 plus 1, minus 1. If I take 1 by 4 here, then 2 into 1 by 4 plus 1, which is 3 by 2, and so on. If I take root 2, for example, then 2 root 2 plus 1. So here image is, you can see, positive integers 0, irrational, and so on. So we can say that the range is R here, all real numbers. And it's always true. Remember, we note that this is always true. We note that range of linear function, any linear function, remember, range of I'll add the word any, range of any linear function from real numbers to real numbers, that is domain should be R and codomain should be R, is all real numbers, that is R. That is, I'm trying to tell you RF equals to R. But remember, domain and codomain should be R. So this is very important remark. You can use this in MCQs. Range of any linear function I mean function of this type, ax plus b. If it is from real numbers to real number, that is domain should be R and codomain should be R, is R, that is RF equals to R, all real numbers. You will get every number on the right hand side for any function, whether I take this, any function, you can see that the range will be all real numbers, RF equals to R. Now next we want to see graph of any function in general. Here we draw the graph of a linear function. So first question in our mind is, what is a graph? So it is nothing but a representation. It's a representation of a function in a form of diagram, in the plane, in the Cartesian plane. So what we do, we first find all such points x comma f of x. You take one number from the domain, find the value of the function where x belongs to the domain of the function. We find all these points, all possible points, x comma fx. We plot this point on the Cartesian plane. Plot the points in the plane, and then you draw a freehand curve. Draw a freehand curve through these points. Freehand curve through these points. This is what in general definition of graph. Graph is presentation of all these points x comma f of x. Suppose I have chosen 0, this comes from the domain. This you can choose from the domain. 0, then find f of 0. Ordered pairs now, if you recall. Take 1, then find f of 1. Take 2, find f of 2, and so on. So plot these points in the plane. Draw a freehand curve through these points, so we'll get the graph of the function. This is what in general we'll do for any function. Now here we are not going to use the graph paper, we'll just draw in our book. That's called function, rough function we'll see here. Now here linear function especially represent a straight line. In a diagram it represents a straight line. So graph of any linear function will be a straight line. Now you know from geometry, to draw a straight line you required two distinct points. For a straight line you required two different points. So minimum 2 points you need. You can use 3, 4, 5, anything, but you know two different points determines a unique line, so we use 2 points. So for example, here I'm drawing for this fx equals to 2x plus 1. This is a linear function, you know. We are drawing the graph for this. So usually we prepare such table, x and fx. X you can choose any number of your choice from the domain. Your domain is always R. Suppose I have chosen 0, put here, so f of 0 will be 1. Next I'll take 1. You can take 2, 3, anything you wish. Suppose I have taken 1, so f of 1 will be 3. So you have two ordered pairs. 0 comma f of 0, that is 0 comma 1. Look at it, this 0 comma f of 0, 0 comma 1. The another ordered pair is 1 comma 3, 1 and f of 1, which is 3. If you want, you can take some more. Suppose I have taken minus 1, for example. Put minus 1 here. So 2 into minus 1, so I'll get again minus 1. This is third ordered pair. But you required minimum 2 ordered pairs. So this and this will give us the answer. So what I'll do, we are not going to use the graph paper. This is just a rough graph to understand the concept of the graph of a function. You know x-axis, y-axis. This is origin. Here you have positive numbers, you know. Here you have negative numbers, you know. Here you have positive numbers, 1, 2, 3. You know, here you have negative numbers. You also know that these are the quadrants: first quadrant, second quadrant, third quadrant, and fourth quadrant. Now we present this you might have studied in 9th standard. 0 comma 1 in the Cartesian plane, 0 from x-axis and 1 from y-axis. So we'll get this point. This is 0 comma 1, 0 comma 1, you know, this point. Next you choose 1 comma 3. So 1 from x-axis. Here fx means y usually, remember. So this comes from y-axis. So here 1 from x-axis and 3 from y-axis. So 1 from here, 3 from here. This is second point. If you want to choose third point, minus 1 from x-axis and minus 1 from y-axis. So this point. You can see that all points are falling on the same line. So you'll get such a line. This is straight line, remember. You can use foot ruler. I'm just writing directly here, drawing directly here. This is a straight line. So this is called the graph of fx equals to 2x plus 1. Straight, remember. You can use foot ruler, but not on the graph paper, just in your book, remember. If you take more points, all points will fall on this. Just 2 points suffice. I mean, by 2 points you will get the line. So this is called a representation of a function by drawing a diagram. So this is called the graph of the function. This way. So one more, if I try, fx equals to 2x. You know that this is also a linear function. So graph will be a straight line. So we prepare this table. X and fx, this is also called y here sometimes. You choose any x of your choice. Suppose I choose 0. So if I put 0, this is 0. If I choose 1 here, then this is 2. Minimum you require 2 points. If you want, you can take more number of points. For a straight line I'm talking. Now I'll represent, if I take 2 for example, you'll get 4. It's a double. Now I represent these points on the Cartesian plane. So you know that this is x-axis, horizontal line. This is y-axis, standing line. These two are always perpendicular. X-axis, y-axis. You have positive number. This is origin. 1, 2, 3. Here 4. Minus 1, minus 2, minus 3. This is 1, 2, 3. If you want 4 here, minus 1, minus 2, minus 3. Now we represent 0, 0. 0, 0, its origin, you know this point. 1, 2. So 1 from x-axis, 2 from y-axis. 1 from here, 2 from here. This one, 2 will do here. But if you want next point, 2, 4. 2 from here, 4 from here. This plotting of points, you know, from 9th standard. Now we draw a freehand curve. Here we know that graph is a straight line. For any linear function, graph is always a straight line. So this is a straight line. There is a graph of function y equals to fx equals to 2x. This is called the graph. It is always a straight line. For any linear function, graph will be always a straight line. And for straight line, you require 2 distinct points, remember. So there is a graph. You can try furthermore if you want. But in general, we have this. Now we go to next point, that is called quadratic function. Quadratic function, which you did in 10th standard. So y equals to fx equals to ax square plus bx plus c. This is called quadratic function. So here you notice that Earlier you had power 1, now it goes to 2. So you have increased the power. So whenever power is 2, then this is called quadratic, or sometimes it's called the parabola. Parabola, remember. This second degree curve, here power goes to 2. Such functions, these are the quadratic functions. If I write x square plus x plus 1, if I write x square minus 1, if I write 2x square plus 3, these are all quadratic functions. If you look at this two, here a is 1, b is 1, c is 1. Here a is 1, x term is not there, means b is 0, and c is minus 1. Here a is 2, x term is not there, means b is 0 and c is 3. So these are nothing but the quadratic functions. Now here for this quadratic functions, graph need not be a straight line. Graph need not be a straight line, but a graph will be always in cup shape, remember. Graph will be always in cup shape. Now in such graph you required 4 or 5 points. 2 points will not gives you the correct answer. So for example, if I try for this fx equals to x squared, this is a quadratic function. Here a is 1, b is 0 and c is 0. This is a quadratic function, remember. I want to draw the rough diagram. So I'll prepare the table x and fx. This is sometimes called y. If I take 0, here image will be 0. If I take 1, your answer will be 1 square 1, 0, 0, 1, 1. If your linear function, 2 points gives you straight line, but for other than linear function, such functions are called non-linear, you need some more points. Suppose if I take 2, here it is 4. If I take minus 1, answer will be 1. If I take minus 2, answer will be 4, and so on. So now I'll try to present these points in the Cartesian plane. Let me see, like this here. This is x-axis, this is y-axis here. Let me use foot ruler. This is x-axis, this is y-axis. You are not going to use the graph paper, remember, just you draw in your book only. Now here you know this is origin. Here you have 1, 2, 3, 4. Here again you have minus 1, minus 2, minus 3, and so on. This is 1, 2, 3, 4, and so on. Now first 0, 0, it is this origin. First 0, 0 origin. 1, 1, it is this point. 1 from here, 1 from here, this point. 2, 4, 2 from here and 4 from here, so this point. Next, if you select, it will be 3, 9 somewhere here. Now I'll go the other side. Minus 1, then 1, this point. Minus 1 from here and 1 from here. Minus 2, then 4, so it is here, minus 2 and 4, and so on. Further you can do. So it would be like this, not in a straight form, it is in this form. It would be like this, remember. It would be broader and broader from both the sides. This is a graph of quadratic function, which is also called a parabola. This is a graph of this function. It passes through origin. Now here, for any function, whether it is this or this, graph always may be like this, or like this, or like this, but it is always in that curve form for any quadratic function. In general, to draw a graph, it's not easy task, but for linear and quadratic functions, you can understand. This is a parabola. It is always in such cup shape form. For any function where the highest power is 2, graph would look like in this curve form. I've shown one. This is a quadratic function. It's called parabola or second degree curve. Now in general, if I take fx equals to this function, a0 plus a1 into x, a0 constant, a1 constant. You see that this is a linear function. Highest power is 1. I'll add next term, a2 into x square. So this become a quadratic. Next, I'll write a3 into x cube, this cubic, and so on, in general an into x raised to n, where this a0, a1 up to an all are constants. An should not be 0. So this is called a polynomial function. You might have studied in 9th standard. This is called polynomial function. Polynomial function of degree n. Degree is highest power of x. What is the highest power of x? Which is n. So polynomial of degree n. If I look up to this is a polynomial of degree 1, which is linear. If I look at up to this is a polynomial of degree 2, which is quadratic. If I look at up to this is a polynomial of degree 3, which is called cubic. But in general, we have such a polynomial of degree n. If I write this, fx equals to, for example, 4x cube minus 4x plus 1. So this is nothing but polynomial of degree 3. Highest power is 3 here, remember, polynomial of degree 3. This is sometimes called cubic function. This is sometimes called cubic function. If I write one more like this, fx equals to, if I write 4x square minus 2, you know that this is a polynomial of degree 2. So this is our quadratic function. Quadratic function, remember. If I write like this, for example, fx equals to 4x7 plus x squared plus x minus 2. So this is a polynomial of degree 7 because highest power is 7 here. Now this is not polynomial, remember. If I write like this, 3x raised to 4 plus 2x raised to 3 by 2 plus x raised to minus 1 by 2, not a polynomial, because in a polynomial power should be always positive integers. You see here 1, 2, 3 and n. Here powers are in fraction. So this is not a polynomial, This is not a polynomial. Now up to quadratic, you know, if your linear graph is straight line, if your quadratic graph is that cup shape, but for higher order polynomial it's not easy to draw the graph. So up to quadratic you need to keep in your mind. If you have this, for example, if I write this 4x minus 3, you know that this is a polynomial of degree 1. This is nothing but in our language linear function, linear or straight line function. So for at least such functions, if you have linear function, graph is straight line. If your quadratic, graph is that cup shape. But for higher order functions it's not easy. So we mainly concentrate for these two, linear and quadratic functions. Next is modulus function. So here function from R to R, real numbers to real numbers. Fx equals to this one, modulus x. This is read as modulus of x. Fx equals to modulus x. You might have studied earlier what in general modulus does. It converts the negative number into positive. For example, if I take f of 1 here, you know modulus of 1 is 1. If I take 2 here, you know modulus of 2 is 2. If I take minus 1 by 2, you know modulus of minus 1 by 2 is 1 by 2. So if it is negative, it converts into positive. If I take minus 4, you know modulus of minus 4 is 4. If I take 0, you know modulus of 0 is 0. If it is 0, it remains as it is. If it is positive, it remains as it is. But if it is negative, it becomes positive. This is the definition. So here I'll write like this, where fx equals to x if x is positive, greater than 0. See, here number is positive, so answer is itself. Here number is positive, answer is itself. But if number is negative, if it is less than 0, here, so inner number is negative here. You see here inner number is negative, so it became positive. Now if I want to make minus 4 to positive, what I need to do, I need to put one more minus sign in front of it, so it becomes 4. So if number is negative, I need to put minus sign in front of it, so this become positive. Here it looks minus, but remember this itself is negative, like minus 4. So minus 4 and one more minus sign gives you plus 4. So this is a concept of modulus. Fx here, fx is modulus. So what is the definition of modulus? Modulus equals to x if number is positive. Modulus x equals to minus x if number is negative. When you choose 0, the answer is 0. तो यहाँ पे आप 0 लेंगे तो 0 आएगा, तो मैं greater than or equal to 0. So this is the definition. I repeat here, modulus x equals to x if number is positive. Replace by itself. आप 0 रखेंगे तो 0 आएगा, तो I'll take greater than or equal to 0. But if I choose negative number, if x is less than 0, here you see less than 0 means negative. अब देखो ये negative है, modulus of minus 4 4 हो गया. Suppose I'll write modulus of 2 minus 2 sorry, तो ये 2 हो जाएगा. कैसे? Minus of this number which is minus 2, so it becomes 2. So what you did basically, in front of this inner number you have placed minus sign. So if number is negative, you put minus sign in front of it. So this is the definition of modulus function, very important definition. Now you can put fractional value, but answer will be always, you know, positive. So here range will be all positive real numbers. You can write sometimes r plus, but 0 bhi aa raha hai, so union 0. So you can write in terms of interval close 0 to infinity. 0 से start करके all numbers. Suppose there is a real line here 0, so all these numbers goes to infinity. This is called r plus union 0, including 0. R plus means positive real number with 0, union 0. Or this is same as close 0 to, it goes to plus infinity, like this. So this is the range of modulus function, this one. Now what about graph? Let me see the graph of modulus function. So here for the graph of the function, I will not draw the table because here points are there. So this is the x-axis, for example, here horizontal line. This is y-axis. This is y-axis. Now you have some positive numbers here, 1, 2, 3, here your minus 1, minus 2, here your 1, 2, 3 and so on. Graph will not be below x-axis because all values are positive. First I have taken 1, suppose I have taken 0, 0, 0, so this one. If I choose 1 here, then answer is also 1, so 1, 1 this. If I take 2, then 2, 2. Because it's positive. If I take 3, then 3, 3 this way. If I take minus 1, then answer of minus 1 is 1. So here, if I take minus 2, then image will be 2. If I take minus 3, then image will be 3. So it would be like this. Here you have one ray starting from origin. It's a straight, remember. This is another ray starting from origin. So here, graph is union of two rays. Union of two rays. Graph of modulus function is always union of two rays starting here from origin. It may not start from origin always. It may be like this also sometimes. You may have graph like this also depending upon the modulus function which you have chosen. Maybe like this also. But it is always union of two rays. This is a straight starting from origin. This is a straight starting from origin. Remember in parabola you had something like this curve shape. That is a cup shape. Cup diagram if you remember. Here it is a straight path. You have exactly corner over here. Here you have cup shape. That's the difference in parabola and modulus. So you can try for graph of modulus x minus 1, modulus x plus 1 and modulus 2x plus 1. You can just try in rough papers. You will see that the graph will be union of two rays. Try for this. I will go to next type, fifth one, which is called signum function. It's called signum function. Now here function from real numbers to real numbers. It is defined in this way. It takes only three values. 1 if number is positive, 0 if number is 0. If positive, then answer is 1. If 0, then answer is 0. If number is negative, then answer will be -1. So signum function takes just three values, 1, 0 and -1. For example, for signum function, what is f of 2? This number is positive, so value will be 1. What is f of 4? This number is positive, so 1. What is f of 100? It will be 1. What is f of 1000? It will be 1 because this number is positive. What is f of 0? 0. What is f of -200? Answer will be -1. What is f of -400? Answer will be -1. What is f of -1/2? Answer will be -1. For any negative number, if I write f of 4/3, this is positive number, so answer will be 1. This is a signum function. So obviously, signum function takes how many values? Just three values, 1, 0 and -1. Every time either it is 1 or 0 or -1. So range will be just three numbers, 1, 0 and -1, range of signum function. Graphically, how it looks like this, you see, if this is x-axis, for example, here this is y-axis, this is y-axis, this is origin. If I take any positive number, that is this, then answer will be 1 always, all these numbers. So this way. For 0, it is 0. 0 is not included here. If I take negative number, if this is -1, if I take here -1, then the value is -1. If I take -2, value is -2. If I take -3, value is -3. So this way, this is a signum function graph. 0 is included here, remember. For negative number, this ray. For positive number, it is this ray. It's a step function. It's not continuous graph, you have break. Remember, 0 is not included here, 0 is not included. If you take, for example, 0.5, then it is this. If I take 1, then it is this. If I take 2, then it is this, all these numbers. If I take 0, then it is this. If I take minus, then this number. So this way it is a graph. This is a graph of modulus function, and range is just three numbers. The next one is greatest integer function. This is also sometimes called box function or floor function. Greatest integer function. So it's a function from R to R, real numbers to real numbers, where fx equals to, this is a symbol, box of x, or sometimes just close from lower side. That's what is called floor. What's the definition? Definition is greatest integer. We are writing meaning of this, greatest integer. So answer will be always an integer, that is 1, 2, 3, 4, something like this. Greatest integer less than or equal to x. This is the definition of box function or floor function. Greatest integer less than or equal to that number. This is the definition of box function. It's called floor function or greatest integer function. So what I'm trying to tell you is, let's see what the meaning of this. Suppose I want to find f of 1.5. Let's see this. That's a box of 1.5. Now you draw the real line, you will realize further. Suppose this is 0, here you're 1, here you're 2, 3, -1, -2. Where is 1.5? Here. You know that this is 1.5. Now find all integers less than or equal to that number. So you know 1, 0, -2, -1 and so on. Among all these integers, these are the integers less than or equal to 1.5, 1, 0, -1, -. Among this, which is the largest integer, that is 1. So answer is 1. I repeat what I did. You have 1.5 here. Get all integers less than this. Integers, remember. So 1, 0, minus 1, minus 2. But these are infinitely many integers. Among all these, which is the greatest? That is 1. So 1. If I write, for example, box of 1.6. So 1.6 here. Now again you find all integers less than 1.6. That is 1, 0, minus 1, minus 2. Among all, which is the largest? That is 1. So here again 1. You can see very easily if I write 1.9, 1.9 is somewhere here. Get all integers less than this. That is again 1, 0, minus 1, 2. Among all these integers, which is the largest? That is 1. So box of 1.6. Even if I write box of 1.1, naturally it is 1. 1.1 is somewhere here. But if I write box of 1, now 1 itself is an integer, so answer will be 1. If I write box of 2, 2 itself is an integer, so answer is 2. If I write box of 4, obviously it would be 4. If I write box of minus 2, being an integer, value will be minus 2. If I write minus 1.5, now you see what happens. This is not an integer, it's a fractional value. Where is minus 1.5? I suppose here. Now go to all numbers which are less than, all integers which are less than minus 1.5. So minus 2, minus 3, minus 4 and so on. Among all these, which is the largest? That is minus 2. So answer will be minus 2, remember. If I write, for example, minus 0.5, where is minus 0.5? It is here. So minus 1, minus 2, all integers which are less than minus 0.5. Among this, which is the largest? Which is minus 1. But if I write 0.5, your answer will be 0. Why? 0.5 is here. Now what are the integers less than 0.5? That is 0, minus 1 and so among these, which is the largest? That is 0. So answer is 0. Now if you observe all this, the one line answer is 1, 1, these are all integers, but all these numbers are first integer from left side. So you can write these also, first integer from left side. First integer from left side. So if I am standing here, 3.6 for example, which is the first integer from left side? That is 3. So box of 3.6 is 3. If I'm standing here, so suppose minus 2.8. Minus 2.8 is somewhere here, which is the first integer on the left side, which is minus 3. So answer is minus 3. So range of this function, it is always an integer. So here range of this function, box function, range of fx equals to box x is z, all integers. Remember, it's z, all integers. Now I'll try for the graph of this function. So I'll consider two coordinate axes here. Now here for the graph, if I take 0, then it is 0. If I take 0.1, box of 0.1 is 0. 0.2, 0. 0.3, 0. And so on. So it will be this only. Just 1 minute, let me draw on another page. So here, suppose if I take x and fx here, you can do directly also. If I choose 0, then it will be 0. If I take 0.1, then you know box of 0.1 is 0, and so on till 0.999 it is 0. So you are getting these ordered pairs: 0, then 0, 0.1, then 0, 0, then 0, 0.1, then 0, even 0.5, then 0, till 0.99 you are getting this. So starting from 0 it is this. Remember, 1 is not included here, so I'll put open circle. Now as soon as I select 1 here, then the value will be 1. So graph will move here. It would start from here. If I take 1.5, answer will be 1. 1.5, answer will be 1 here. If I take 1.4, value will be 1. 1.4, this one. 1.1, this value. All these values will be there. Till which number? Till 1.999, for example. Again 1. Till 1.999. So this is a strip. This is still 1.99. As soon as I take 2, then f of 2 is 2. If I write 2, then it is 2. So 2, then it starts from here. So 2 is not included here. I'll put open circle. There is 2 में यहाँ पे 2 आएगा. 1 पे यहाँ पे ओपन सर्कल रखा मैंने, तो 1 पे यहाँ से चालू हो रहा है, 2 पे यहाँ पे स्टार्ट हो रहा है, 1.99 तक यहाँ पे. If I select 2, then it start from here. 2.1, then this. Till which number? Now you must realize till 2.999 here. Till 2.99. As soon as I select 3, graph will start from here. 3. Then it moves like this. 3 यहाँ पे नहीं है, 3 यहाँ पे है. Remember, this is till 2.999. Then this and so on. If I go for this here also, -1, then -1 here. This value. If I take this number, then again -1. This is -1, you know, like this. But 0 पे यहाँ पे नहीं है, 0 पे यहाँ पे. It starts from here, 0, then 0. Then here -2, then this, then this. So it will be like this. This is also step function, remember. You have various steps here. This is not continuous graph. यहाँ पे एक jump आ रहा है, यहाँ पे भी एक break आ रहा है, यहाँ पे भी एक break आ रहा है. So this is very important graph. This is called the graph of box function.